Today, we will turn one vertical gap on a scatterplot into a relative residual. The arithmetic is short, but the order matters. Predict from the line, compare the observation with that prediction, use the denominator named in the definition, and only then convert to a percent.
Here is the exact workbook prompt. A scatterplot relates x to y, and the line of best fit is y equals 3x plus 18. The highlighted observation has x equal to 12 and y equal to 62. The question defines relative residual using the predicted y value.
The source choices are 454 over 27%, 8%, 400 over 31%, and 400 over 27%. Those similar fractions are designed to expose whether we chose the correct difference, denominator, and percent conversion.
Before calculating, read the source visual. The blue line is the line of best fit. The highlighted red point is the actual observation. At x equal to 12, the vertical segment from the line to that point represents the residual.
The observed y value is 62 because that comes from the highlighted data point. The predicted y value is not printed as a separate given. We must obtain it by placing x equal to 12 into the model y equals 3x plus 18.
Substitute 12 for x in the line of best fit. 3 times 12 is 36. Add 18, and the model predicts 54.
Now compare actual with predicted using the standard residual order, observed minus predicted. 62 minus 54 equals positive 8.
The positive sign has meaning. The observation lies 8 y units above the line at x equal to 12. If the point had been below the line, observed minus predicted would have produced a negative residual.
The enlarged graph confirms those values. The teal point on the line marks predicted y equal to 54, the red point marks observed y equal to 62, and their vertical separation is 8.
This question asks for the absolute value of the residual, so direction no longer matters in the numerator. The magnitude is the absolute value of 8, which remains 8.
Next, follow the definition exactly. Divide the absolute residual by the predicted y value, not by the observed value. Our numerator is 8, and our denominator is 54.
Simplify 8 over 54 by dividing numerator and denominator by 2. That gives 4 over 27. At this point, we have a ratio, not yet a percent.
To express the ratio as a percent, multiply by 100%. 4 over 27 times 100% equals 400 over 27%.
That exact value appears in choice D. It is about 14.81%, but the source choices use exact fractions, so 400 over 27% is the strongest final form.
Let us verify the scale against the picture. A gap of 8 compared with a predicted height of 54 should be a little less than 15%. 14.81% fits that estimate.
We can also reverse the percent calculation. 400 over 27% means 400 over 27 divided by 100, which is 4 over 27. Multiplying that ratio by the predicted value 54 should recover the residual magnitude.
And 4 over 27 times 54 equals 4 times 2, or 8. The reverse calculation returns the original vertical gap exactly.
A second method keeps the expression in one line. Substitute the model prediction directly into the definition. Take the absolute value of 62 minus open parenthesis 3 times 12 plus 18 close parenthesis. Divide by that same prediction, and multiply by 100%.
Evaluate the brackets first. 3 times 12 plus 18 is 54. The numerator becomes the absolute value of 62 minus 54, and the denominator remains 54.
So the one-line method becomes 8 over 54 times 100%, which simplifies to the same exact result, 400 over 27%.
The multi-step method is safer for interpretation because each number gets a name. The one-expression method is faster once the definition is secure. Both methods rely on the same model prediction and the same denominator.
Trap 1 is reporting 8% because the residual is 8. 8 is measured in Y units. It becomes a relative quantity only after division by the predicted value, and it becomes a percent only after multiplication by 100%.
Trap 2 is dividing by the observed value 62. That would create 8 over 62, or 4 over 31, and then 400 over 31%. That is choice C, but it contradicts the problem's stated denominator.
The graph makes that denominator choice visible. The baseline for the comparison is the teal predicted point on the line, y equal to 54. The red observed point supplies the actual value used in the difference.
Trap 3 is forgetting the percent conversion. 4 over 27 is about 0.1481. As a percent, that decimal is 14.81% because we multiply by 100.
Trap 4 is reversing the residual subtraction and then ignoring the absolute value. Predicted minus observed would be -8, but this problem explicitly uses an absolute value, so the numerator magnitude is still 8. The sign only describes direction.
Now try a transfer example. A model predicts y from x using y equals 2x plus 10. At x equal to 15, the observed y value is 46. Define relative residual the same way, absolute residual divided by predicted y, expressed as a percent.
First, calculate the prediction. 2 times 15 plus 10 is 30 plus 10, so predicted y equals 40.
Next, calculate observed minus predicted. 46 minus 40 is positive 6, so the point is 6 y units above the model. The absolute residual is 6.
Divide 6 by the predicted value 40, then multiply by 100%. 6 over 40 is 3 over 20, which is 0.15, so the relative residual is 15%.
Verify the transfer result in reverse. 15% of the predicted 40 is 6, exactly the observed to predicted gap. And because the observation is above the model, adding 6 to 40 recovers 46.
Notice the reusable structure. The line of best fit gives a baseline prediction. The residual measures the vertical discrepancy in original y units. Dividing by the specified baseline removes the unit, and multiplying by 100 expresses the comparison as a percent.
For the source problem, the model predicts 54 at x equal to 12. The observed value is 62, so the residual magnitude is 8. Relative to the predicted 54, that is 8 over 54 times 100%.
The final graph check is consistent. The observation is above the line, the vertical gap is 8, and 8 is a little under 15% of 54.
Therefore, the exact source answer is choice D, 400 over 27%.
Predict, subtract, take the magnitude, divide by the predicted value, and convert to percent. Following that order turns the scatterplot's vertical gap into the correct relative residual, 400 over 27%.
Optional SAT math study resources are linked in the description. If you purchase through an affiliate link, the channel may earn a small commission at no extra cost to you. As an Amazon associate, I earn from qualifying purchases.